Okay, let's dive into a polarization problem. Here's the question we're looking at. Imagine you have unpolarized laser light with a wavelength of 602.8 nanometers. This light passes through two linear polarizers. The cool thing is, these polarizers are positioned at a 30-degree angle relative to each other. The question is, what is the amount of light that actually gets transmitted through that second polarizer? And here are the options provided for us. A. Is it 100% of the incident light? B. Maybe it's 75% of the incident light? C. Or perhaps 50% of the incident light? D. Or is it 25% of the incident light? Let's figure out the correct answer. To solve this, let's start by defining our terms. We let I0 be the intensity of the light before it hits any polarizers, meaning the intensity of that initial unpolarized laser light. Okay, so for step 1, let's think about what happens when the light goes through the first polarizer. When unpolarized light, like our laser light, passes through an ideal linear polarizer, its intensity is cut in half. It essentially blocks out half of the oscillations. After passing through, the light isn't unpolarized anymore, it becomes linearly polarized along the transmission axis of that first polarizer. So, the intensity of the light after it comes out of the first polarizer. Which we'll call I1, is simply 1/2 of the original intensity, I0. We can write that as I1 equals 1/2 I0. Now for step 2, we look at what happens as this light goes through the second polarizer. The light leaving the first polarizer is now linearly polarized and its intensity is I1. This polarized light then hits our second polarizer. Remember, the problem tells us this second polarizer is placed at a 30-degree angle relative to the first one. So the angle theta between the polarization direction of the light arriving at the second polarizer, which matches the axis of the light arriving at the second polarizer, which matches the axis of the first polarizer. And the transmission axis of the second polarizer is exactly 30 degrees. So to find out how much light gets through the second polarizer, we need to apply a key principle called Malus's law. Malus's law tells us that the intensity of light transmitted through a polarizer, when the incident light is already linearly polarized, is given by the intensity of the incoming polarized light times the cosine squared of the angle between the light's polarization direction and the polarizer's axis. In our case, the intensity of the light transmitted through the second polarizer, I2 is equal to I1 multiplied by the cosine squared of theta. That's I2 equals I1 cosine squared theta. Now let's substitute what we know. I1 is 1/2 I0 and theta is 30 degrees. So we get I2 equals, in parentheses, 1/2 I0 close parentheses times the cosine squared of 30 degrees. Alright, step 3 is to calculate that cosine squared of 30 degrees. The value of the cosine of 30 degrees is the square root of 3/2. So to find the cosine squared of 30 degrees, we just square that value. It's the square root of 3/2 all squared. When we square the fraction, we square the top and square the bottom. The square of the square root of 3 is just 3 and the square of 2 is 4. So the cosine squared of 3/2. So the cosine squared of 30 degrees equals 3/4. Now for step 4, let's calculate the final transmitted intensity, I2. We take our equation, I2 equals 1/2 I0 times the cosine squared of 30 degrees. We just found that cosine squared of 30 degrees is 3/4. So we substitute that in I2 equals 1/2 I0 times 3/4. Multiplying the fractions, 1 times 3 is 3 and 2 times 4 is 8. So I2 is equal to 3/8 times I0. Step 5 is to express this result as a percentage of the original incident light. To do that, we calculate the ratio of I2 to I0 and multiply by 100%. So we have the fraction I2 over I0 times 100%. Since I2 is equal to 3/8 I0, the ratio I2 over I0 is simply 3/8. So we need to calculate 3/8 times 100%. Let's finish step 5 by doing that calculation. 3/8 as a decimal is 0.375. So we calculate 0.375 times 100%. That gives us 37.5%. So the amount of light transmitted through that second polarizer is 37.5% of the original unpolarized light intensity. In conclusion, we calculated the result to be 37.5%. Let's compare that to the options we were given. A 100%, B 75%, C 50%, D 25%. Based on our calculation using Malus's law, the correct physical answer is 37.5%. It appears that value wasn't listed among the provided options. However, following standard physics principles, 37.5% is the accurate amount of light transmitted in this scenario.